Well, many thanks for giving this opportunity to talk about our research. The title somehow explains what we are doing. The reason is very simple. We observe on one side for many years that applications which are used for simulation, especially in medicine, are becoming more and more complex on one side. On the other side, there is an increasing possibility to use different type of computing storage infrastructures. So it would make impression that it will be very simple to just to use them, but the situation is not so simple, and we are involved in this research for some time. And what I would like to tell today, it is experience we have learned from collaboration with our colleagues from medicine, from Sheffield University mostly, and also where they intend to build the systems which finally will be used in practice. So this is outline of my talk. I will start from motivation and go through different, let's say, approaches to solve this problem. And so this is a typical situation we face in when people are trying to do valuable research in medicine. First of all, they already learned that the great idea of virtual physiological human, where everybody could have his own computer model and which would be used when you come to a medical doctor, is not achievable. The only one solution is to use results of scientific investigation to build decision support systems which will be placed in clinical environment. And for the transfer between these two environments is not straightforward. It is a transfer which can be done by updating this decision support system based on the research, based on intensive simulations. And well, the reasons are many, but anyhow, the key to success of these decision support systems is in successful simulations. And this is an example of such a flow of simulation. Example from the research we have just completed somehow. It was about building decision support system to help in diagnosis and curation of all these diseases which are related with your heart, with valves in the heart. So first of all, in order to be useful in the clinical environment, you need to have models which will be relatively simple, which can run in this clinical environment. You cannot imagine that people in clinic will just use supercomputers during their practice. So there is a lot of effort to build models which are characterized by a very low number of parameters, which present organs in practically in 0 dimension. And for this reason, it's one type of effort goes to build such models, and in order to build them, it's necessary to run a number of computational fluid dynamic simulations and elaborate what is called reduced order models based on many approximations. So, for example, it is activity which is done by ANSYS. On the other hand, when you have such a model, you still have, for example, as it was at the very beginning here, something like 50 parameters. You need to reduce this. You need to investigate how the model is sensitive to different parameters. So you need to run a quite large number of simulations. And these simulations should be run by different researchers, by different group of researchers. And for this reason, what is extremely important from this practical point of view is reaching reproducibility, in the sense that the same results can be obtained by different teams working on different, let's say, experimental setup. I mean here different type of e-infrastructures. And this is the main objective. And well, our task is to, let's say, to find available solutions in software solutions and to put them together in order to reach this stuff. So this is something what was used in the framework of this project for something like 3 years, organizing access to both to compute resources and to storage, different type of compute resources in different way. And I'm not going into to details of this figure, but anyhow, it should be suitable for different type of users. And it means we have learned that even if there are some perfect solutions on the level of, let's say, middleware, it is not enough to provide them to just to users. So here is well, a kind of a slide which presents how it looks, this environment from a side, and at the same time it presents what type of functionality can be provided for different type of users. Anyhow, it was, you can see it was from these statistics, which is, I think that the most important what was here. And I would like to stress on this. It is number of releases which were produced during this time of this project. So it is not true that if you offer a kind of a solution to a user, the user will start use it without any help. So here, this flow of computation you have seen was not extremely complex. But anyhow, we had something like 13 releases of this, which were built because of enrichment of features. And of course, there were releases which were related to detected bugs. So you need this type of layer, and we have identified during this collaboration with our colleagues that you have to deal with 3 or 4 categories of users. First of all, the perfect type of user is an end user who just builds using a kind of a scripts, can build a pipeline, may call this also workflow, to perform a specific simulation. But even in such a case, you will have simulations which will be stopped in the middle, and you need tools which enable to handle something which will be similar to provenance. You have model providers, people who have a, let's say, knowledge from a given area and are able to to propose a kind of solution. Sometimes they come with solutions with MATLAB, because it is a tool in which they are working, and then you can imagine what is the problem if you would like to put this into high-performance infrastructure. Based on these solutions, you need to provide a kind of services, and finally you have a group of administrators and operators. Of course, you can find somebody who will be able to play all these four roles at the same time, but the question is how it will be, let's say, efficient. And environments should be organized in such a way that they will serve for this. So it is a story. The story I told before was exactly the same we have learned when we were involved in building a kind of cloud platform. A cloud platform for sharing. And the idea was that in this virtual physiological human, let's say, community produce a lot of models of human organs, and well, it would be reasonable to have a kind of repository, a working repository, where these models could be put available for ready for be used by different group of users. So it was the main idea, and yes, of course, we have also a category of end users, a category of service providers, and cloud technologies were quite useful to organize something like this. Finally, we were able for this process organize to put together in the federation private and public clouds, providing a kind of accounting system. But anyhow, all these solutions were quite heavy from the point of view of what we know at that moment. But anyhow, well, if you look at this, there was something like 250 what we call atomic services, modules from which it was possible to build using just cloud technology to build different type of simulations. And well, originally the project started with something like 4 typical medical applications. Finally, if I remember, it was something like 25 this type of applications built on the basis of this project. Of course, we have profited from what was done, and we have used the same approach, first of all, as a tool in Polish, what is called PL Grid infrastructure for scientific community in Poland. But besides of this, it was also used for something quite different than medical applications, namely for simulations of floods, and of course it was somehow linked to our model execution environment for these valve simulations. Well, at that moment, we are participating in research which we can call towards exascale. So it is a kind of infrastructure research. Yesterday, Reggie has told something about this. Fortunately, there is still medical application inside, so we all the time up to now in this work. And the idea is to test how a kind of platform for this exascale computing should look like. Of course, in the framework of this project, there will be no exascale computer available to to partners of this project, although we have in the project Dieter Kranzmiller together with his, let's say, staff in Garching. So, and after the project is almost in the middle, and after many discussions, many investigations, we decided that this proof of concept will be based on singularity. Well, it was the discussion presented that it is suitable for high-performance computing, and because of supporting of something like NPI, GPU, and it will fit to demonstration of this platform. And well, the 4 points which I presented here, which are important also for our team from the point of view of reproducible research. These 4 points are possibility of putting this in one file, possibility of including NPI GPU support. They are, from a point of view of reproducible research, really important at that moment. And so the, well, a kind of, let's say, this platform looks like this, and we have a just singularity part, and it is a kind of, let's say, a way in which it is used in the framework of this solution. I think that, well, it is a figure which presents that it works, but it doesn't matter. Here is a sample process pipeline with medical application and based on the usage of singularity. So we have quite positive experience up to now with this solution. Maybe because of the time, now we are in the beginning of investigations which looks like quite complex simulations for medicine. They are all around cancer disease, but it seems that the project has just started. But the promise is that it will be interesting because of diversity of different type of approaches to simulation of this. Starting from computed fluid dynamics, using, on the other hand, there are some agent approaches of different type of scale. So it seems that it will be necessary to compare the results of different approaches, and it will be necessary to build a kind of environment for enabling something like this. So on one side we have, I don't know why it is called in such a way, but anyhow we have a pool of models and algorithms, and on the other hand we have data lake, which will be governed in many places. And the idea is that using this containerization approach to build a system which enable to run the same containers on HPC cluster, and on the other hand on cloud resources. So this is something which is ongoing research, just a preliminary concept. And we are also, my colleagues are using containerization in the process of software building. So This is something which, according to what they say, makes their life simpler. If you recall the number of this, let's say, releases of the software in during the URVALV project, it is something which using containers enable to automate the system, automate the process to exchange between our team members. So the next slide is probably not visible too much, but anyhow it is a kind of illustration of producing of consequent builds of the system. Well, there is another, let's say, there is something which, another type of activity, and well, we are just in our team trying to understand to which extent it could be used for building reproducible simulations, namely serverless infrastructures. So, well, it's a kind of, let's say, evolution in development. They are probably on this evolution. It is a stage which is completely different from traditional virtual machines, and it seems that well, we can define functions and build on top of these functions. So, well, granularity which can be achieved here is quite interesting. And what we already, there were some two publications which are related to this of my colleagues, and what they are trying to understand, they are trying to, first of all, to benchmark these two, and then to link this with our Hyperflow engine, which is a kind of workflow system. It could be any other workflow system used to this, but what is important for this is that it is relatively simple. So, maybe this opportunity, it will be another opportunity to try to build a reproducible software. So, well, in summary, I can say that really we observe this kind of evolution. At that moment, from the point of view of providers of, let's say, this type of middleware, we have something which can be called serverless containers from Google, for example. And well, the main objective is to have something which will be relatively simple to manage, but at the same time, it will be elastic for this group of users, because there is not a single type of user of such a simulation systems. And of course, there is another problem which probably needs additional discussion because this evolution means increasing of abstraction layers. To which extent it is it can introduce additional errors, and what to do when all this stuff will appear. So I think that well, this word is which when you hear some, let's say, tutorials about, for example, simplicity or other type looks, it is not so boring like these tutorials. So this is what I can say. And if you are interested in what was done in the framework of this project, or what will be done in the framework of process and Primage, well, just you are invited to look at our website. Thank you for your attention.